Every time we think Java has finally settled down, it shows up again with a new release looking sharper, stronger, and more flexible than before. Hey everyone, welcome back to Coding Wala Shree. I'm Shree, an architect with over 16 years of experience, primarily in designing and building distributed systems. I'm also an AWS certified developer and a Neo4j certified professional. I have worked on large Java enterprise applications, decomposed monoliths into microservices, built with Java, Kotlin, Node.js, and designed event-driven systems using messaging platforms like Apache Kafka, RabbitMQ, and Solus, deploying them on cloud platforms such as AWS and GCP. For this video, I have gone through dozens of JEPs, that is JDK enhancement proposals, across multiple Java releases, traced how each feature evolved, and summarized everything that truly matters in Java 25. So, you don't have to dig through release notes, I have got you covered. So grab your coffee because we are about to explore what makes Java 25 smarter, cleaner, and more developer friendly than ever. Let's start with something simple. Remember those compact source files and instance main methods feature we explored back in my Java 24 feature review video? This feature was first introduced in JDK 21, and after a few refinements across versions, they have now been finalized in Java 25. With this, Java 25 takes another step towards helping beginners, students, and instructors learn the language more easily, letting them write simpler programs before diving into Java's heavier concepts. The idea is straightforward. You can now write your first Java program in a clean and concise way and gradually scale it up as your skills grow. In other words, you don't need to understand everything about packages, classes, and static methods in the very first program you are writing in Java. So here is a classic Java program that we have been writing for years. So for a beginner, it will also be heavier to understand and explain. It is great for production, but a bit intimidating for someone just starting out. So in Java 25, you can write the same thing much more simply. Our compact source file in Java 25 becomes like this. Just 3 lines. Void main, that is the simple entry point. And IO is a static class which offers println overloads and readline overloads, which basically wraps around system.out and system.in for standard input-output related operations. And that's a simple compact code you can write concisely as your first Java program and run it successfully. So a few key points to remember: no need to declare a package, no need for a class declaration even, and our main method is not static. It is an instance main method. And again, the IO class, it was first introduced in JDK 23, but was in java.io package, which is moved to java.lang package so that it is available by default without any explicit imports. So isn't that amazing? Now, just to be clear, this compact syntax is great for learning, quick experiments, or teaching. But enterprise level projects should still follow the classic Java structure with proper class declaration, package, and build tool. Why is that so? Because it's a fantastic feature easing the learning curve, but real world code bases should still rely on this structure because readability, maintainability, and clarity matters after all. If you missed my detailed demo on this, check out the Java 24 feature review video. I have covered it there with hands-on examples and use cases. Link will be in the description. For now, let's move on to the next important feature in Java 25, that is module import declarations. The concept of modules was introduced back in Java 9 as part of the module system. What it does, it allows a set of packages to be grouped together under a single name for reuse. We will explore modules in depth in another video, but for now, let's see what's new in module import declarations. I have created setup of a multi-module project to save some time. Here I have 3 modules: com.codingwalashree.app, com.codingwalashree.client, and com.codingwalashree.utils. My com.codingwalashree.app module, I'll call it app client and utils modules for easier references. So my app module uses utils module. Okay, there is a general utils class which has been used by this app module, and for this setup, I need to define a module info.java file in every module. We are defining here an app module which is depending upon the utils module, as I explained. So I want to expose this service package to the outside world, and also the model where I have one record. I want to expose these 2 packages to the outside world. That is a setup I have. So if I go to my client where I'm using this app module, so in my module info in the client, you can see that it requires the app module. Now if I go to the app client, it is just instantiating order service and payment service and making call to their method. For that, what we used to do is we need to import these particular classes. You can imagine if there are more than 100 classes, you need to import all the classes those you require. So your code piles up with all the import statements at the top. So to get rid of it, module import declaration is one smart way to import all the classes or packages exported by the module. So I know that these order service and payment service, these two classes belong to the app module. So I can just use module import syntax for that. So as soon as I import this module, these classes are resolved, and that's what this feature is. You can basically import particular module and all the classes and packages in that particular module will be available, and you need not import them individually. So this single statement saves you from writing a long list of repetitive import lines. So this is cleaner, simpler, and much easier to maintain. That's a quick feature, module import declarations. Okay, next one is something every Java developer can instantly relate to: flexible constructor bodies. You know that rigid rules we have always lived with. The first statement in the constructor must be either this, that is call another constructor in the same class, or super call, that is call parent class constructor. Flexible constructor bodies were first introduced as a preview feature in Java 22, refined in 23 and 24, and finally standardized in Java 25. The problem before this feature was introduced in Java 22 is in earlier versions of Java, if you wanted to do even tiny check or calculation before calling another constructor, you were out of luck. It was not allowed. Check out this employee constructor with a single parameter name. So it is calling another constructor in the same class with two arguments, name and salary. So this was necessitated to be the first line. You can't do anything before this constructor call. If you dare to put any code before this call, then boom, compiler error. Java constructors rule were as flexible as a concrete wall. So what's new introduced in Java 22 and later finalized in Java 25 is new flexible constructor bodies feature began losing these restrictions, and it's now finalized in Java 25. You can perform certain limited operations before delegating to another constructor, like input validations, logging, or parameter normalizations, something like this. So the same code I can write like this. So I can validate my inputs. This is now allowed, and now I am delegating call to another constructor. So you can finally validate parameters or tweak values before chaining constructors without those awkward helper methods or factory hacks we all wrote at some point. So what are the key takeaways? Constructors are still strict. You can't access this or instance fields before delegation, but now you get flexibility to prepare data and keep constructor logic clean. In short, Java restrictions finally learned to relax a little, just enough to make our lives easy. Next up, we actually talked about this in my Java 24 feature review video, but it's worth a quick recap. Yep, I'm talking about primitive types and patterns, which extends pattern matching to work with primitive types inside instanceof and switch statements. I covered this feature in detail with demos in my Java 24 feature review video. So if you haven't seen that yet, make sure to check it out after this one. So quick recap. Before this enhancement, pattern matching didn't support primitive types. It worked only with reference types such as classes, interfaces, arrays, records, or wrapper types like integer, double, long, but not with primitive types. That led to a classic boxing unboxing punches we have all thrown at some point, right? You can now match directly on primitives. No wrapping, no unboxing is required. So consider this example, which we have already covered. So like this, you can use it in instanceof and directly match it and at the same time convert it into the required type. Similarly, in switch statements, you can do something like this object and you can match it to int, or there are guarded case statements as well. These are called as guarded case statements where you have condition and then only you match the pattern. So yes, you can even add conditions directly in your pattern. Here, checking if double value is greater than 2 is a condition which we applied, and when it will come to the third case is when the double value is of course less or equal to 2, right? That is, it is handling the smaller ones separately. So what is key takeaway with Java 25? Pattern matching for primitives continue to evolve, now in its third preview and almost ready to go stable. I have already covered it with demos and examples in my Java 24 review video, so do check that one out if you want to see it in action. Now let's talk about something that sounds advanced but actually makes concurrent programming much simpler: structured concurrency, currently in its fifth preview in Java 25. Analogy to understand it: imagine if you are managing a kitchen, you assign two chefs for two different tasks. One is preparing pizza and other is preparing Coke. So as a good head chef, you don't leave until both are done, right? Once both dishes are ready, you serve them together. That's exactly what structured concurrency does. It runs tasks in parallel, waits for all of them to finish, and lets you combine their results safely. So the core API, that is Structured Task Scope. This feature introduced a new API, Structured Task Scope, which lets you define a scope for running multiple subtasks together. Think of it as manager ensuring all subtasks start, finish, or fail in a clean, predictable way. For example, we are extending the example of the chef's kitchen. Let's say in our main method, we are creating new subtasks using this scope, which is nothing but from structured task scope dot shutdown on failure. So we are using structured concurrency API that is introduced in API to actually create the subtask and then join. That is, we wait for both the tasks to finish, and then once they are finished, so this is a main thread that has created these two subtasks, now getting their result and joining them, combining them. So here is our quick sample example to define how structured concurrency works. Here, both tasks run in parallel. One prepares pizza and other prepares coke. The main thread, that is our chef, waits for both before serving. If one fails, since we are using shutdown on failure, other is automatically cancelled. It's a clean, structured way to handle concurrency. No dangling threads, no manual cleanups, and no hidden error. So what is key takeaway? Structured concurrency helps you treat multiple subtasks as a one logical operation, making concurrent code easier to read, reason about, and maintain. Now, traditionally, we would use an executor service and manage everything ourselves, submit tasks, wait for results, handle shutdowns, exceptions, and the whole deal. But structured concurrency takes care of all that for us. It's like focusing on the business logic and not the thread management. Next up, scoped values, which have now been finalized in JDK 25 after several preview rounds. Quick recap. I have covered scope value in details with demos and examples in my Java 24 feature review video again. But here is a quick refresher. Scope value lets you share immutable data safely across methods or tasks without relying on thread local. Why it matters? In older Java versions, we use thread local to store data tied to a thread like user IDs, transaction IDs, and so on. That worked fine until virtual threads arrived, first previewed in JDK 19 and finalized in JDK 21. Virtual threads are extremely lightweight and many of them share the same underlying OS thread. This means the data stored in thread local can leak or behave unpredictably across virtual threads sharing the same carrier thread. Scoped values solve this. They let you bind immutable data to well-defined scope, automatically cleaned up when the scope ends. So, finalization summary. Scoped values were first introduced in JDK 20, stayed in preview from JDK 21 to 24, and now in JDK 25 they are finalized and production ready. And just to clarify, Java isn't forcing you to migrate away from thread local. The goal isn't to deprecate it. Scoped value is a simply safer and modern alternative, especially suited for structured concurrency and virtual threads. In short, scoped values lets your thread share the context, not confusion. If you have already seen my Java 24 videos, you know how scoped values simplify context sharing. In JDK 25, they are no longer experimental. They are stable, efficient, and ready for production use. Let's take a quick look at security updates. Java 25 also enhances its security libraries with a new key derivation function, API, that is KDF, a standardized secured way to derive cryptographic keys from passwords or shared secrets. This updates prepares Java for post-quantum era. As quantum computing advances, classical encryption algorithms will face real security threats. So JDK 25 adds built-in support for post-quantum cryptography, that is PQC, offering stronger, future-proof key protection. In short, it's Java getting ready for next generation of secure applications. There are a lot of performance improvements too in Java 25. One key update is compact object headers, which reduces the size of object headers to 64 bits, that is 8 bytes, on 64-bit platforms. This means a smaller heap footprint, improved memory layout, and overall better performance, especially in applications handling millions of objects. Another interesting addition is ahead-of-time method profiling. It allows the JVM to collect method usage data even before runtime, helping the JIT, that is just-in-time compiler, make smarter, easier optimizations. So while these changes happen quietly under the hood, they make your applications faster, lighter, and more efficient. So that's all for today's look at Java 25, a release that quietly but powerfully polishes the platform. We started with simpler, learner-friendly feature like compact source files and ended with deeper, developer-focused ones like scoped values and structured concurrency. Along the way, Java 25 has cleaned up syntax, strengthened modularity, improved concurrency, and even stepped into future with post-quantum cryptography and compact object headers for better performance. In short, it's another solid step in Java's steady modernization journey. If you enjoyed this quick tour, don't forget to check out my earlier videos, especially my Java 24 review where I covered scope values and pattern matching in details. Drop a comment if there is any feature you would like me to explore deeper in a separate video. I would love to hear your thoughts. Thanks for watching. This is Coding Wala Shree signing off. See you in the next video.